get our recording started and get our fun going for today. Let me get my screen back up here. All right, what do we want to do? Here we go. All right, looking at our map check for today. Obviously, tonight is all the fun is over or starts or whatever way you want to look at it. I don't know how much sense that makes, but the bottom line is the Way of the Warrior project is due tonight, no later than 7 p.m. I know some of you have turned it in already. I look forward to reading those projects tonight, and that's on Canvas. What's we're going to do today is we're going to talk about hypothesis testing when the proportion mean is sigma, the population standard deviation is known. So those situations, what do we do in those situations? We'll call this 4-pack 2. What's not on this map check is something I'm doing tomorrow night. That's Wednesday night at 7 p.m. as part of YCP's Excel series. I'm doing a presentation on leadership through crisis. So it is purely optional. Number one, it's on Zoom. Number two, it's at 7 p.m. Number three, so it will probably be recorded if you don't want to tune in at 7 and you want to watch it later. And if you don't want to do any of that, that's cool too. I always enjoy seeing you, and it would be cool to see you on the Zoom tomorrow night, kind of get me hyped. But it's not about me, it's about you. So if you're interested in that, you can get the information by emailing me directly, or you can check your email for YCP activities is how the information has gone out in the past. Or you can contact Nate Taylor. He's the staff member in charge of the Leadership Excel series at YCP. So that's tomorrow night. Again, purely optional. Looking back in terms of this course and what we're going to do, looking at Thursday, we're going to go through our final section of how to do hypothesis tests. So Thursday will be proportion mean hypothesis testing when the standard deviation is unknown. And then that'll close us out for hypothesis tests. We'll go into next week and talk about regression on Tuesday, and then we'll start getting our act together for our final preparation for the final exam. In between all of that, this Sunday, Pearson is due. I'm trying to think of the homework numbers. I think it's just one homework number. Escapes me right now. But actually, I think it's 3. It's 3 Alpha, 3 Bravo, and Charlie. That sounds like a lot. But the truth is there's only 2 problems in each. Okay? 3 Alpha deals with what we did last week. 3 Bravo deals with what we're going to do today. And 3 Charlie will be what we're going to do on Thursday. So wherever you're at, I encourage you to finish up with your Way of the Warrior project. Get that in the box. Get that nice and pretty the way you want to. And as soon as you can get into additional reps on Pearson, please go ahead and do that. What's not on the agenda here? Let's see if it's on my next one. Yeah. So recording, that's actually happening right now. The practice packs. So let's just go ahead and pull that up. So we've all got an idea of where that is. All right, let's see here. All right, a little bit of technical difficulties on my end. Okay, so if you go to your Canvas, and what are the practice packs? So what I did down, got that thing called lag. All right, so I know my view looks a little bit different than you, but you should be able to see all this. So a practice pack. So for example, this practice pack is for hypothesis tests with the population mean, standard deviation known. And then that's what we're going to do today, that kind of hypothesis test. And then we have the ones that we did last week. So let's just go at the ones we did last week, proportion hypothesis testing. All right, strength through repetition. So let's just crack this open and see what we're talking about. This is all on Canvas for you. So, all right, so it doesn't look that super great on the screen, but the bottom line is it's a Pearson problem with the answers provided. So if you're doing Pearson, you could always look in here and see if there's a similar problem. We know the values always change. That might be able to help you. But the main thing is that if you want more repetitions beyond what we're doing in class and you don't want the penalty hanging over your head for getting the wrong answer, these practice packs are out there for you on each type of hypothesis test. Okay, so those are all there in Canvas for you to use. Okay, so enough on that. All right, so I talked about practice packs. Today we're going to do a little thing called the frame game to kind of warm up. And so we can identify what type of hypothesis test something is, and then maybe even do the null and alternative. We'll do that real quick, just 3 quick rounds, and then we'll get into the meat of the matter, which is today, which is not proportion hypothesis tests. It's the mean hypothesis testing. So here is where we are today. Here in the yellow, we're going to talk about population mean hypothesis tests and when we know the population standard deviation. Okay. This area up here, population proportion, was where we were last Thursday. And then down here with this Riddler question mark, population mean with sigma unknown, is where we're going to be on Thursday. So again, this might seem kind of repetitious. If it does, that's good. I'm just trying to get you comfortable with where we've been, where we are, and where we're headed. To drill deeper into this yellow box, just as an overview, when we talk about population mean, when the standard deviation is known, we're going to use the Z distribution and the Z statistic. And in this situation, we could have either a two-tailed test or a one-tailed test. And then from there, we could do both of these, both with either the critical value method or the p-value method. So this yellow box, this yellow rectangle is where we're going to be today. But before we get into that, we'll play a little bit of frame game. All right. So we're just going to do this to kind of warm up a little bit. Let's check it out. Marissa and Tori both work for Slurp. Slurp is a sports drink company. Each can of Slurp is supposed to contain 20 ounces with a standard deviation of 0.3. So this should say Marissa and Tori. Sorry about that. So this is M and T. So they head out to pull a sample of Slurp and validate that Slurp production is working as it should. So what we're going to do here, just in a frame game, is we're going to talk about the null and alternative hypothesis. That's all we're going to do. We're not going to solve this. We're not going to do the full hypothesis test. So let's see here. George, what do you think the null is?
Uh, 0.3 or 20 ounces.
Okay, just 20 ounces by itself.
Or population mean equals 20.
Okay, so Alyssa, if that's the null, what would the alternative be?
That the mean does not equal 20.
Okay, good. And Lexi, what are we looking at here? This is a population mean problem. Do we know the standard deviation of the population?
0.3 ounces.
Yep, that's what that is. So that right there is sigma. Okay, just a tiny little warm up. Let's do another one. All right, according to a recent report, 0.48 or 48% of people have quit working out since the quarantine. Max does not think this is accurate. So, Max, what do you think the null hypothesis is?
The 48% of people who've quit working out.
Okay, what about the 48% of people that quit working out?
That is the that's the assumption, but
Okay, Megan, help him out. What do you think? What's the null hypothesis here? I think your mic is muted.
Oh, sorry. P is greater than or equal to 48%.
Okay, let's back up a step. So what type of hypothesis test is this? Is this a proportion or a mean? What do you think, Megan?
I want to say proportion because it's a percentage.
All right, super. And so we want to use this, right? P-pop. Okay.
Yep.
Yep. All right, cool. So we're going to put that there. Now, let's look at, and hey, remember everybody, we're the penguin, right? So we're just doing this as a warm up. We're just doing this to get skills down. All right. So don't, that's what that is. Jack, based on this, how would you complete the null?
So it would we do less than?
Okay. What do you think, Eric? What would you put in here?
The null would be the equal sign, and then the alternative would be does not equal.
Why do you say that?
I kind of thought of the alternative first. So since Max does not think it's accurate, he thinks it does not equal 48%, and then that would mean the null equals.
Okay. Good. Everybody hear that? So Max, the thing about this is Max, at least yet, he's not specifically going in one direction or the other. So Max doesn't necessarily, at least he's not saying that he thinks it's greater than or less than. Like Eric said, he just doesn't think this is accurate. And so that's why we would put that there. Okay. So it either is or it isn't, which is what this is saying. And Max is saying, hey, I don't think it is. We don't know what Max believes. Max may think it's 0.5. Max may think it's 0.47. We don't really know, but it kind of doesn't matter. As long as Max says, hey, I don't think this is accurate, this is not only good enough, but it's relevant to put there right now. All right, we're going to do one more, and then we're going to get in today's fun. Now, this last one is a little bit tricky. That's why I got Run DMC down here, because it's tricky, right? And I know that song is like kind of boomer thing. It's like anyway, it's a good song. I don't care how old it is. All right, so let's check it out. Gianfranco makes T-shirts. Over the past 2 years, it has taken an average of 7.45 hours to make a shirt with a standard deviation of 0.5 hours. 3 weeks ago, he hired 4 new workers. Gianfranco now wants to see if his average shirt making time, say that 5 times fast, has decreased to 7 hours per shirt. All right. So, Joel, what do you think the null hypothesis is?
I'm trying to decide here if it's going to be the population mean is equal to 7.5 hours or 7 hours, but it says he hired 4 new workers, and he's trying to see. So I would presume it's probably, is it 7?
Okay, so the question is it 7 or 7.5? All right, so I'm not going to answer that. I think that's a good question to ask. That's a very relevant question to ask. So, Thomas, what do you think? What should that null be? And connected to that, is it 7.5 or is it 7?
It's gonna be less than 7 or less than equal to 7.5 hours.
Less than or equal to
Yes.
is in the null.
Yes.
Okay, and what symbol goes over here?
Would it be mu?
Okay, I'm not saying that this is kosher. I'm just writing down. So let's see who else is out there today. Trent, what do you think about all this? Do you think this null is right, or would you choose something else?
I think the 7.5 is right, but would it be equal, or yeah, equal to, instead of less than or equal to? And then would it be p-pop?
Okay. So what do you think, Hannah? What are your thoughts on this null?
I think it would be mu is less than or equal to 7.
Kendall, what do you think?
I think it's mu equals 7.5.
All right. So this is a tough one. Hence, these dudes run DMC. It's tricky. Okay. This is the status quo. And status quo is synonymous with HO. Okay, so we at least have mu is equal to 7.5. Now, how we alter that depends on what Gianfranco thinks and therefore wants to test. And so because he thinks it has decreased, all right, then this would have to be that, because the null would be that it's less than 7.5. All right. Now, a couple things before we move on, and this is why I brought this one in here, is so that everybody can, again, I can't necessarily walk downstairs and bench press 300 pounds, but I get some benefit out of trying. Okay. So it's worth it to struggle on this. I would rather struggle on this now than later. Okay. So a couple key things here before we move on. Number one, the equal sign of any form or fashion is always in my null and is never in my alternative. Okay, cool. This number is the same. We began with Joel saying, I'm not sure if I should decide on 7 or 7.5, which is a valuable question, to wrestle over. The reason we put 7.5 in here and not 7 is because this 7 at this point is really less relevant than this 7.5. Why is that? Because the 7.5 is the status quo. And in hypothesis testing, we first want to either reject or fail to reject the status quo, which is the null. Okay. We'll get after the 7 later. But by this hypothesis testing, all right, if Gianfranco did end up rejecting the null, then it would begin to support his belief that it has decreased. Not necessarily down specifically to 7, but that it has decreased. Let's look at this has decreased. Okay, that means that the mu is now less than 7.5, which means that it has decreased from 7.5. Okay, so this, just so we make sure that we're looking at, is a population mean hypothesis test, and it is a one tail. Okay, and we could do it either using the critical value method or the p-value method. How we choose to do that in the real world would be your choice. In this class, I'll probably tell you I want you to do it this way or that way. Kind of like the Backstreet Boys, I want it that way. Maybe not. Not a Backstreet Boys fan, so don't be thinking that. Okay, so any questions on this right here or any of this part of the frame game? Okay. So again, we always want to put a null in there first, okay, and then reject or fail to reject the null by making the alternative connected to the null. Now, just before we go on, if you look at this again, you go, well, wait a minute. They're out to see, what's the alternative? Well, we only have a null. We only have a status quo. So it actually is pretty simple. The null is it equals 20, and then the alternative is that it does not equal 20. And one more thing I wanted to talk about on this one. So an average is our keyword here toward it's a population mean. Whenever we see average, that's synonymous with mean. That's a keyword towards a population mean type of hypothesis test. In contrast, this percent, whenever we see a percent, that's usually a cue that we're looking at a population proportion kind of situation. Okay, so those are, and I'll make sure that these are posted. I think I already have them on Canvas. If not, I'll double tap and make sure that they're there. Okay, so we'll go into the fun for today, which is actually don't have it open. Have everything else open, but not that one. Super.
I have a question.
Okay.
So if the null is equal and the alternative is not equals, that's two-tailed, and then okay. All right. I was just trying to understand the difference between those two.
Yeah. Does that answer your question, Greg?
Yeah. Yeah.
Okay. All right, here we go. That's what we're going to do today. Hypothesis testing. I call this 4-pack tube. The bottom line is that we have a situation where the population mean is what we're dealing with. We're testing that. And our standard deviation or sigma for the population is known. Okay. And so here's our hit list for today. We're going to be dealing only with that kind of situation, population mean, sigma known. We're going to look at a problem where we have a two-tailed situation and a one-tailed situation. And in contrast to the last time we did this, I altered the problem a little bit between our two-tailed situation and our one-tailed. And we'll talk some more about how that goes. So we're going to do this problem 4 times. Essentially 4 different ways. So here's our situation. You became the manager of Good Burger about 1 month ago. And the provision on which you were hired, the manager told you, hey, welcome, you've got the job, but the time to place orders that customers, from the time that a customer stands in line to the time they place their order, is taking too long. Or we could even extend it from the time that they stand in line to the time that they get their order. It's taking too long, and I want you to do something about that. So those are your marching orders why you got hired. So you were hired 1 month ago, you did an assessment of the situation, and you put 5 things into place to decrease customer order time. Now, it could be 10 methods, it could be 1 method. The 5 methods doesn't really matter, okay? But what you want to find out is, after 1 month of working there, has the order time gone down? Has what you have done been effective? Okay, so this is our setup. And so now it's time to find out. You're going to do that by doing a hypothesis test. So we're going to start out with a population mean two-tail critical value. Okay, so same question. Just let me get my pen back up. All right. So again, in the future, like we did on the frame game, I'm not going to tell you the frame. You'll have to figure out that frame. All right. We know that we have a mean waiting time. Mean is synonymous with average. So that's a cue that we're dealing with the population mean. And you want to determine if the time to place an order has changed from the previous time of 4.5. So when you were hired, the manager said, hey, it's currently 4.5. I think that's too long. All right. You want to just see if it's changed. So there's that kind of open-ended. In this test, you're not necessarily assessing if it's increased or decreased just yet. You have this here that it's changed. All right, let's read on. From past experience, you can assume that the population of waiting time is normally distributed. Okay, that's helpful, with a standard deviation of 1.2 minutes. So just like Lexi identified during frame game, this 1.2 is our population standard deviation, or sigma, which puts us into this type of hypothesis testing. All right. And then we have some other information right here. So let's see here. Brianna, what do you think is the null hypothesis?
Is it P-pop is equal to 4.5?
Okay. I like everything here. What did you want to put here?
I guess maybe it's not P-pop. Oh, okay, so it's mu then?
Yep.
Okay.
Okay, because we don't have a proportion. We have a mean. Okay, so good. If that's there, then this would be not equal to 4.5. Okay, and again, this is a two-tailed. It could have gone up, it could have gone down. We're not looking at it. We're just trying to see, do we accept that it's still 4.5, or do we reject that? So that's step number 1 over here. And oh, by the way, these method steps are the same for any hypothesis test that we do under the critical value method. So this box we've seen before. So the level of significance, alpha, and sample size. Okay, so we have right here that alpha is 0.05. It's not always 0.05, but I just use that for this problem. And so, Cynthia, what is our N if you look at these gray boxes?
Would it be 36?
Outstanding. Okay, so that takes care of step number 2. We have alpha, we have sample size. All right, number 3, determine our appropriate test statistic and sampling distribution. in terms of our sampling distribution, when we have this situation where we have the population mean and we know what sigma is, we are still going to roll with Z. And so we're going to roll with the Z statistic. It's not the same as the formula we used last week, because the formula we used last week was for the population proportion. However, it is a familiar formula. We're going to lead with X bar. We're going to minus the mu. We're going to have all of that over sigma over the square root of n. That's going to be our formula for determining the test statistic. Okay? Again, we've seen this formula before. We've used it in sampling theory. All right? And it's the same formula. Okay? So again, when we have the situation where we know what sigma is, we can use the Z distribution and the Z statistic. So that takes care of step number 3. Okay, critical value time. When we're with Z and we want to get critical value, we're going to go to our Z-hack table. Remember this dude? Okay. And so we're going to go down here. Let's just start with the yellow box. Only use with hypothesis tests involving population proportion. No, that's not what we have here. Okay, well, it's number 2. Hypothesis tests involving population means and standard deviation. I really should rewrite that. Here we go. Sigma is known. We're under that condition, so we can use this. Now we go back up. Do we have a two-tailed or a one-tailed? We have a two-tailed. Our alpha is 0.05. So our critical values are both positive 1.96 and negative 1.96. All right, super. So get back up here, get my stuff back up. Boom. And so I'm going to go ahead and draw. Okay. So my rejection region out here is going to be 1.96. My rejection region over here is going to be negative 1.96. Say, so I'm going to put rejection region here, rejection region here. In the middle, do not reject. Okay. And the point of all this, another way of putting this is decision rules. So if my Z-stat, once I put my numbers in here, is greater than 1.96, meaning it falls out here, I'm going to reject the null hypothesis. If my Z-stat falls out here, meaning it's less than 1.96 negative, it's less than negative 1.96, I'm going to do the same thing. I'm going to reject. But if it falls in between, I'm not going to reject. I'm going to fail to reject the null hypothesis. So let's see where we're at. We're somewhere down here on step 5. Because we just finished step 4, determine the critical value. We got that off our hack table. And we built our rejection and non-rejection region. So we're done with step 4. Now, collect the sample data. Okay, so I'm starting to run out of room. I'll put it up here. We have X bar equals 5.1. Okay, the sample mean is 5.1 minutes. That means X bar is 5.1. We already have N, 36. We already have our level of significance, 0.05. We almost don't need that anymore. What else do we need for this equation? We have sigma, which is 1.2. So let me put this in right here. Just try to see if I can get myself a little bit more room. Sorry. All right, let's see how that looks. Okay, that does the trick. So X bar 5.1 minus my mean mu, which is 4.5. Sigma 1.2. N 36. Square root of 36. When I put all this in, I get a z-stat of 3. Okay? So, Justin, do I reject my null hypothesis based on this z-stat, or do I fail to reject it? Justin, I don't know if you're muted or what. Travis, what do you think? I got a z-stat of 3. Do I reject or fail to reject this null hypothesis based on a z-stat of 3?
I joined late, so what was the outside number?
So this critical value here is 1.96.
Mm-hmm.
And my z-stat is 3. My critical value over here is negative 1.96.
Oh, so reject it.
Yep. Because 3 lands way out here.
Mm-hmm.
Okay. So the statistical decision, reject the null hypothesis. Now, this is kind of, I don't know, this is kind of a tough question. Tim, what do you think? So in context, if I reject this null hypothesis, and you're the manager, let's say you're the manager of Good Burger, right? So you're going to reject this null hypothesis, which states that the mean times are equal to 4.5. What do you do now? Do you celebrate? What do you do?
Well, I guess now the next step. So if you can say that it rejects to the right side, does that means it's greater than? So does that technically mean that the order time is higher than 4.5?
Yeah. So Tim is
Okay.
on to the right thing. We rejected the null, but I wouldn't celebrate yet because look at that. That's that 5.1. That's greater than that 4.5. Now we have a sample size of 36, so you might say, well, let's just get some more samples. But the probability is that this mean has actually gotten worse since you've been hired. So in context, I would say, oof, I kind of need to probably go back to the drawing board and see what I need to do to get this mean to move over here. Okay. So it's a little bit kind of a tough one to put into context. All right, let's look at this doing the p-value method. So here we have the same problem. We're just going to solve it using the p-value method. Get my pen fired up again. All right. So we remember that our null, again, the problem hasn't changed at all. Just the way we're going to do it is we're going to do it with the p-value method. So we're still dealing with mu equals 4.5 and mu does not equal 4.5. Okay, so that's step one. Step two, choose the level of significance and sample size. Well, level of significance is right here, 0.05. And the sample size we determined was 36. So thus far, nothing has changed. Let's go to step number 3, the appropriate test statistic and sampling distribution. Well, because nothing has changed, we have a population mean situation where we know sigma. So we're going to roll with Z. And that's our distribution. And then in terms of our statistic, our Z stat, again, is equal to X bar minus mu over sigma divided by the square root of N. Okay, so that hasn't changed. All right, cool. Collect the sample data. All right, we have this, we have everything we need. Compute the value of the test statistic. We still have that. So our setup here, again, we're going to take X bar, which is 5.1. We're going to minus 4.5. Our sigma is 1.2. Our sample size is 36. So that's our setup. And we know now that that equals 3. Okay, compute the p-value. All right, so last time I said this whole norm dist false, and I don't know why I did that, what I was thinking. So we don't want to use that on an equation. We can use that one of two ways, or we can do this one of two ways. We can do it this way, and we put 3 and then true. All right, now when we do this, we're going to need to do a 1 minus with that answer that we get. Or we could look up 3 on a Z table. And if we look up 3 on a Z table, we will get 0.9987. But we're talking about this kind of thing. And that number there refers to this number. So we got to do a 1 minus. And when we do that, we get a 0.0013. Now we can't stop there because we know this is a two-tailed test. And the reason we know that's a two-tailed test, because of that right there. It could either be greater or less than. So we need to take that times 2. 2 for the two tails. So p-value is 0.0026. Line up, everybody line up. That comes from a CD my kid used to watch when he was a kid. He still is a kid. Anyway, so if I put alpha over here and I put that there, alpha is 0.05. That is my p-value. The question is, if the p-value is lower than the alpha, then reject the null hypothesis. That's my way of saying that differently. And this is indeed less than alpha, so I would reject my null hypothesis, which makes sense particularly because we already did this problem and we already rejected the null hypothesis. So just because we did this a different way, we should still come up with the same outcome. If you like the alligator and the fish, here's the fish, a greater value. The alligator is going to go for the bigger thing. So the alligator is going to go for that. And if the alligator eats the fish, then we reject the null hypothesis. Okay? So that's how we do the same problem with the p-value method. Okay? Everything is the same until we start messing around with this p-value. Okay? And again, to get that p-value, we're going to take that test statistic and convert that into a probability the same way we would as if it was just a z-score, because it is a z-score. We just call it a z-stat because we're doing a hypothesis test. And then the final thing we do, because it is a two-tailed test, we want to include that same probability on the other side. So that 0.0013 refers to this side, but because it's two-tailed, we want to include the same probability that it could be over here. So those two added together equals that 0.0026. Okay, and then we compare that against the level of significance. Reject, and then same contextual. Don't necessarily celebrate yet because, like Tim said, the fact that this is way out here on the right-hand side doesn't really indicate that the time has decreased the way we want it to. And so, yeah, we rejected the null hypothesis, but really the implication is that times have gotten greater, not less. Okay? Questions on anything we've done so far? All right. Let me take a quick pause while I do something real quick.
Is there ever a time that they don't give you the level of significance?
No. You always have that. Now, what I might do is ask you what level of what type of significance would you choose based on what you're doing? And the short answer is, if you really want to, so let's just take a tangent for a second. Let's say I use a 0.05. I'm kind of opening the door for me to have a false positive and have a false alarm, meaning that I reject the null when I shouldn't be. So if I really want to minimize my chance of error, I would go for that lower number, 0.01. But the short answer to your question, Travis, is I would always, you're going to have this given to you in terms of this class.
You decide, so I know, like if you had to start coming up with them.
Now, in the real world, you're going to have to choose your level of significance. I think what I would recommend to you is, if you ever do this for real, and of course I encourage you to do it for real because now you know how, is I would choose a 0.01. You can't go wrong with that. You can't go wrong with that. So let's look at this. Here I've changed the problem a little bit. So I would like you to cue in on how I have changed it. The first thing I've changed is that it has decreased. You want to determine if the mean waiting time to place an order has decreased from its previous time of 4.5 minutes. Okay? And then the other thing I've changed, and we'll get to this in a minute, is that your sample mean is 4.4 minutes. My pen is getting possessed. Stop! Stop. And I can just do this. Boom. All right. Sorry about that. Some kind of ghost in the machine. All right. Has decreased. And then sample mean 4.4. And let me just talk about this real quick, because this is a great real world example. So you take a sample, you get 4.4, you have an N of 36. And at face value, you might go, well, it has decreased. Why do I need to do a hypothesis test? 4.4 is less than 4.5. So if you hadn't been through this class and you weren't a D3M warrior, you might rush to celebration and go, woohoo, you know, it has decreased. But now that you know how to do this, you go, wait a second. Is this a statistical difference? Okay, is this a statistically significant difference? And that really is the question. So it might be less, but is it less in terms of statistical significance? That really is the question, because it very well might not be. Okay, and this is a distinction. So we're going to run through the hypothesis test. Let's go ahead and check it out. So let's see. I think I've called on everybody here today. So George, what do you think the null is?
The null would be population mean less than 4.5, less than or equal to.
Okay, Megan, what do you think?
Well, I had the same thing written down, so
Okay,
I
you think?
agree.
All right, for the null. What else? Joel, what do you think?
I would say the population mean is greater than or equal to 4.5.
Okay, so what would the alternative look like then?
That would just be the population mean is less than.
Okay, so this is our correct setup. And if it helps you as a technique, one way of doing this, it's not necessarily all the time, but is to put your alternative in first, really, because we want to determine if the mean waiting time has decreased from 4.5. Remember that this is our status quo, that it's 4.5, and we can't put an equal sign down here in the alternative. So if we load our alternative in first, then we just make our null essentially the opposite, which is greater than or equal to. Okay, and then this is our one-tailed test. So other thing I want to highlight before we go on is that where the population mean is in relation to this symbol is the tail that we're going to be working in. So let me see. I think I just want to draw this down here. Okay, so we're going to be working in this left tail. All right, when we set everything up, we're going to be on this side because of this. All right, because of how our alternative hypothesis is set up. Less than 4.5. That 4.5 is right here in the middle, and we're going to be working over here. Okay, so let's go back to our steps. We just did step number 1. Step number 2, we've got it. It hasn't changed, 0.05. Sample size has not changed at 36. Determine the critical value, rejection and non-rejection regions. Okay, this is going to change a little bit because we're in a one-tail. All right. I think I skipped a step. I did. I'm sorry. 3, determine the test statistic and the sampling distribution. Okay, we're still under this situation where we have a population mean and we know the standard deviation. So we're going to stay with the Z distribution and we're going to stay with our Z statistic, okay, which is X bar minus the mu over sigma over the square root of N. Okay, so that part hasn't changed. Determine the critical value, the rejection and non-rejection regions. Okay, this is important. Since we're only doing a one-tail test, our rejection region is going to be somewhere here. Okay. And the rest of the distribution will be our do not reject region. We don't have anything over on this side. And again, to beat that dead horse, the reason we're on this side is because how this symbol is oriented in relation to the mu within our alternative hypothesis. So this is important that you get that mental muscle memory on how to set this up correctly. All right, from here, because we're in the Z distribution, to determine critical value, we're going to go to our hack table. So we're going to go down here. We're still have, okay, we're cleared hot to use this because we're still dealing with the sigma is known. So that's cool. But this time, instead of going over here on the left-hand side, we're going to go on the right-hand side. And alpha is 0.05, but notice how our critical value changes. And because it's a one-tailed test, we're only going to choose either the positive or the negative. We're going to choose a negative because we're on the left side of the distribution, the left tail. We're going to choose that negative 1.645. So we're going to get out of here, go back here. And so this value here, 1.645, refers to that right there. So our decision rule is that if Z-stat is less than negative 1.645, we reject. Otherwise, we do not reject. Okay? Now, collect the sample data, organize the results. Remember, we have a different X bar this time because I changed that. So let's make sure we do our setup correctly. 4.4 minus 5.1. Everything else is the same. 1.2 square root of 36. My chicken is like on the other side of the room. I don't know why that is, but we figure all that out. That actually equals to negative 0.5.
Is it the mu? Isn't that going to be the 4.5, not 5.1?
Yes. I have this backwards. No, I don't have that backwards. Ah, I know what I did wrong. 4.4 minus 4.5. That's what you're saying. Okay, cool.
Yeah.
All right, thank you. That is correct. So this still equals negative 0.5. I just went a little fast on my notes. I apologize for that. So I come down here. So, Trent, do I reject or fail to reject based on this Z-stat of negative 0.5 and a critical value of negative 1.645?
You reject it.
Okay.
Or no, you're going to accept it because it's greater than the 1.645.
Right. So I fail to reject. But yes, that's what the same fail to reject. And that's because that negative 0.5 is like here. Okay. So I would fail to reject. And in the context of the problem, again, I have to go back to the drawing board, or you do, depending on who we're talking about as the manager of Good Burger. Remember, you were hired to decrease times from 4.5. And now that you're a D3M warrior on a clear conscience and knowing how to do a hypothesis test, you can't just tell the boss, well, I did decrease it because it's 4.4 based on this sample. The truth is, it's not a statistically significant difference. Okay? So you got to go back to the drawing board, figure out how to get that order time down. Okay? So that would be the context of the so what. Okay? Any questions so far on this? Okay, we got one more and it's the same problem. We're just going to do it with the p-value. Okay, same. Null is that we're talking about greater than or equal to 4.5. Alternative, mu is less than 4.5. That's step number one. Level of significance, alpha is 0.05. Sample size is 36. A little too much blue on the board, so let's get some black in there. That takes us through step number 2. Step number 3, because we have population mean and a standard deviation, we're still rolling with the Z distribution. And let's see if I can squeeze my Z stat in down here. X bar minus mu over sigma divided by the square root of n. So that takes us through 3. You notice that the p-value, we actually have one less step because we don't have to draw the rejection region and the do not reject region and all that kind of stuff. That's just a side note. All right, number 4, collect the sample data. We have it. We have our level of significance. We have our sample size. We have our X bar. We just need to identify that X bar is indeed 4.4. Compute the value of the test statistic just to make sure that I don't goof this up again. We have from this formula here, 4.4 minus 4.5 over 1.2 divided by the square root of 36, and all that equals negative 0.5. All that has not changed from doing this as a critical value problem. Let's talk about what has changed. If I look up this p-value, negative 0.5 on the z-table, whatever way I do it, if I just go straight to my z-table, I would be on the left-hand side of the z-table. I just go on down to negative 0.5, and I'm going to get a probability of 0.3085. Okay, and that's my p-value. Look how big that p-value is. All right. Pull my level of significance down, 0.05. It's a one-tailed test, so I don't do anything with this. I don't multiply it by 2. It is what it is. Okay, and then I compare these two. Well, that 0.3 right there versus that 0 right there states that this is much bigger than that. And so if the alligator eats the fish, I would reject the null, but the alligator is not eating the fish. The alligator is eating this value over here. If the p-value is lower than the null, the level of significance, then the null must go. Well, if the p-value is low, that is not a low p-value at all. So we are going to fail to reject the null hypothesis. And again, in the context of the problem, means I got to get back to the drawing board. All right. This looks like it's less than, but it's not in terms of statistically significant difference. And, you know, I read papers or I evaluate papers for classes as part of my job. And every now and then somebody wants to say, this is significant or this is a significant difference. And there's always a D3M part of me that kind of like, hey, let's use that word sparingly. Or let's not use it at all in this context, because when we say a significant difference, the first question that comes to mind is, how do you quantify that? And so just when people use it in that way, outside of hypothesis testing, I usually coach and encourage people not to do that. Let's just say this is different or this is a difference. And then it's harder for someone to come and criticize our paper and our argument and our presentation. However, now you know how to evaluate is something is statistically significant or not. And in your mind, you may say, well, I don't really care. And that's fine. But I would raise the question of why not? This is all beyond this course and about being more and more capable and knowledgeable. And so I say, if you can say, hey, we're really certain that this is going on, that would lead to a better decision in real life. If you're talking to a decision maker and about millions of dollars and you've done a hypothesis testing and you could come in and say, hey, it is really a good decision for us to do this or not. I don't know if I would walk in and say, this is a statistically significant difference, because that sometimes pisses some decision makers off because they don't have the education that you do, and that makes them look bad. So you don't have to put it that way, but you can say, hey, I think this is a really, really good idea. And if somebody wants to know more, then you can pull this out and say, here is why. And they may go, wow, I need you in every meeting from now on because you know this and I don't. And as a matter of fact, I'm going to give you a $20,000 raise right off the bat. That's the position you want to be in. That's the position I want you to be in, so that I can be back here eating popcorn and waving the yay, fill in the blank flag, Jennifer, Cynthia, Kendall, Justin, you name it. All right. So that's the value of all this kind of stuff. Questions on anything that we've talked about today or that we haven't, big or small, anything at all? Way of the Warrior, this, Pearson, what movie this is from, anything.
Has anybody had problems with Pearson or no?
I don't know of anybody who has. You mean lately?
Okay.
Yeah. I don't know of any problems as of late. So I'm going under the assumption, and we know what assumptions are, that all that was kind of that period thing is not going to happen. That being said, I think the earliest you can get after Pearson is probably a good thing. Earlier you can get after it, but those are adult choices. What else?
I have a question about the Way of the Warrior project.
Yep.
If we did a recording and like our recording just kind of goes over like everything that we kind of, all the graphs and stuff that we did and all the data that we have, did you want us to just submit the recording, or did you want the recording as well as the Excel file that we use to do the recording with?
I would go ahead and send me all the above.
Okay.
Just so if I want to, I can punch in that kind of thing. If I want to look at both at the same time, if I want to see how you computed stuff, I would just go ahead and send it all. Now with the recording, Tim, I don't know if you're going to be able to submit that on Canvas. You can send that to me direct if that's what you do.
Okay.
Or
Sounds good.
Tim or anybody else. Okay. What else? Other questions? Okay. If there are no other questions, then I will hang out until you clear. I'll post this video, same. And I look forward to your projects. And if I don't see you tomorrow night, I'll see you on Thursday. Have a great week. Take care.
Thank you.
Thank you.